Hello, my name is Andy Schweitzer. Quick little preview of our multiple choice acid-based questions. I'm going to go quickly through here, so follow along. Polyprotic means to donate more than one H. This would be considered monoprotic. This would be considered diprotic. This would be considered triprotic. Therefore, these are both polyprotic. Only thing here that can donate more than one H is this thing is none. This is monoproduct, polyproduct, 3 only. In this case, number 2, which of these include a list of conjugate bases? This would be F negative, this would be SO4 minus 2, HPO4 minus 2. That would be letter B. 3 is not the best question. Something we'll learn more as we go through this year. Typical types of reactions: a metal oxide that is metal oxide. In this case, be this potassium oxide. React with water will produce potassium ions and hydroxide ions. Either way, this is the strongest base available. It's really the only base for that matter. Which is always a product of an Arrhenius neutralization reaction carried out in water. So Arrhenius acid, just a simple definition of a type of acid. HX plus, let's say, NaOH would yield H2O plus NaX. Anyways, we will produce a salt, yes. Water, yes. Will it be guaranteed to be 7? Not necessarily. So 1 and 2 only would be D. Each list contains at least one species that can be considered amphoteric. So amphoteric is something that can be both an acid and a base. Now, for example, your HS negative. HS negative can gain an H to form H2S, or can lose an H to form S minus 2. It can go both ways. Now, technically, you can also be amphoteric if you can neutralize both an acid and a base. Aluminum is an example, a very common example of something that is both amphoteric. It can react with both acids and bases, and just to keep it short. So this one here is amphoteric right here, one that you may not know. Otherwise, most of the ones here are pretty standard. This one is out because this one's amphoteric. The list needs at least one that's amphoteric. I'll cross out, or I should say, I'll cross out anything that's not amphoteric. This is not. Nope. Yes. No, no, no. Therefore, this is my answer. Yes. Well, it's amphoteric, amphoteric, not amphoteric. Amphoteric, not, and not, and not, and not. So either way, B is the answer. All the following apply to the solution prepared by adding potassium carbonate to water. Okay, so we're going to add KCO3 to water. It will dissolve, produce potassium ions and carbonate ions. The carbonate ion will then undergo hydrolysis to produce HCO3 minus 1 and some hydroxide ions. In this case, you should note that this is a weak base. So, liquid phase, which of the following is which I apply to the solution except? So one is going to be false. The pH increase to value greater than 7. Yes, it's basic. The liquid phase, the system remains colorless. Yes, this stuff dissolves colorless. Almost everything dissolves colorless. The electric conductivity of the solution increases. Yes, having ions present definitely will increase the conductivity. The concentration of hydroxide ions in the solution increases. Yes, because we're getting basic. The dissolved species are molecules of potassium carbonate. No, they're not molecules. They don't stay together. They're ions of potassium carbonate ions, and we also have some of these guys as well. This is the one that is incorrect, therefore is the answer. Next one, which applies to a concentration of 15 molar NH3. So we have a weak base that happens to be fairly concentrated. There's my KB. So in this case, it is going to be basic. So therefore, this one is out. It's not. This would be considered neutral. Nearly 100% ionized? No, this is a weak. All ions, molecules present, the greatest number of molecules would be water. Yes. So 3 only. Letter B. Which of the following is the best way to increase the H3O plus ions of an alkaline aqueous salt such as 0.5 molar Na2CO3? Alright, so like I mentioned earlier problem, this is basic. So adding phenolphthalein, that's an indicator that will have no effect. Adding more base will not increase this, it would decrease it. Adding a precipitate, I'm not really sure what that means. You could add this stuff, would do nothing. So this is vague, doesn't really say much really, but in this case isn't going to affect our, at this point, guaranteed to affect our problem. Same thing if we add more solute. This stuff is basic. Adding more of it would simply cause it to be more basic. Now adding more water is actually the answer. In this case you would be diluting the base, and as you dilute the base your hydroxides would drop, and therefore consequently your H pluses would go up. Unique question. Maybe not the best one. It's an odd question. Which is the best description of some species found in a solution of acetic acid? Okay, so we have a weak solution, HX plus H2O yields H3O plus and some X negative. This is a very weak acid, so only a small amount of this stuff's present. Our Ka, which is the value right here, will equal the concentration of these guys. Definitely not. They're two entirely different things. If I were to crank up the initial concentration of the acid, this would increase. My Ka never changes. It's not temperature. That's a big no. The hydroxide ions would equal this guy. No, these are being produced at the same rate, so 1 to 1. So these guys would be the same concentration, but not the hydroxides. This is a no. The anion and water are bigger than the water. The water doesn't have a concentration, so that's a no. There's lots of water too, but it doesn't have a concentration. The anion and the H plus are equal. This is the true, and this is also not correct. Which of the following is the best description that changes occur when one molecule of this guy neutralized to form phosphate? 3 protons are transferred. That H plus is considered a proton. Alright, number 11, it says which best compares the total number of ions present in separate 1 molar solutions of each of these compounds. Now keep in mind, alright, we have K2C2O4. Ionic compound split here. We're going to have 3 particles present. Three things break apart. 1 molar times 3 will be 3 molar. This guy here, KHC2O4, split right here. This will give me 2 particles. This will then ionize slightly to form oxalate and some H plus ions, but not much. So we're going to get 2 molar, 2 particles, plus a little bit more, not much. This guy here, we'll get H2Cl3. Very small fraction of it will flip over to H plus ions and HC2O4. So really, we're not going to be much more than 1. Therefore, this is the highest, followed by this one, and C is therefore the answer. Based on whether you're just a simple ionic compound or whether you're an acid and a weak acid at that. Which range of pH is 0.1 moles of this and 100 moles of that? Well, 1 molar equals X over 0.1 liter equals 0.1 moles. So these moles are equal. Therefore, they'll neutralize. The salt is neutral. Therefore, will fall in the neutral range. All the following, this is going to be, I should have hit enter here a couple times to move this down. Here we have a weak base, weak acid, so we have a buffer. This base is stronger, so it's going to be a buffer that is basic. This is a weak acid, it's conjugate. This is a buffer that is acidic. Just keep that in mind as we jump around here. The next ones we'll go quickly through. This one here is a strong acid. This is doing nothing. This is a strong base, and there's nothing that this can do to override that strong base. And these are weak base, weak acid, weak base, weak acid. It's not a buffer, but the Ks and Kbs are very similar. This is going to cancel out to be darn near neutral, assuming equal concentrations. So which solution of above has a pH less than 7, so it's acidic, not a buffer solution. That'd be letter D. Just the NaOH. Buffer that's acidic. Buffer that's acidic is going to be buffer that's acidic would be letter B. That'd be the next one, 15, buffer solution 710, so a basic buffer. Kick back there again. Was my other one, letter A. Right there. Ammonia and its conjugate. Solution with pH of 7. That's not a buffer solution. Okay, so a basic solution that's not a buffer, that would be D. All right. I'll fix one here in a moment. And a solution of pH of 7. So neutral would be the last one, letter E. Those will cancel out. And I think I might have made a mistake. pH of less than 7, so it's acidic. Okay, it's not a solution. I made a mistake there. That would be C, which would be my acid. All right, a couple things there. Take a look at them. Good luck.